though. It's a miracle of the age being able to pick up the phone and talk to somebody on the other side of the world. But although this needs some very sophisticated electronics connecting the phone together, the telephone itself has remained quite a simple gadget. It's really just a set of push buttons, a couple of switches, a bit of electronics inside, a bell or a buzzer of some sort, and of course the handset. Well, I'll take the microphone out and give it to Rex. The microphone and the earpiece are remarkably similar to those on the very first telephone invented over 100 years ago. If I connect up the earpiece at this end and Rex connects up the microphone at the other end, I should be able to hear him.
Hello, can you hear me, Tim?
Yes, I can. It works very well. This is too faint to work over long distances, but the remarkable thing is that there's no battery in this circuit. It's just the microphone at one end and the earpiece at the other. In this programme, I'm going to look at how the telephone evolved from simple devices like this to become the elaborate international system it is today.
Hello, Tim. Can you hear me?
It had been discovered in 1820 that any wire carrying electricity becomes slightly magnetic. The effect was called electromagnetism. Wrapping the wire round in a coil greatly increases the effect. The extraordinary thing is that until 25 years ago, most of the telephone system was worked by devices based on this simple effect. The first use of the electromagnet, though, was for the telegraph, which in many ways was the forerunner of the telephone. In its simplest form, you simply had a switch at one end, Rex, and a needle at the other. This was made in lots of different varieties. This is one for sending private messages. This is a twin needle one, and you could send all the different letters of the alphabet by a sort of code of different sequences of needle movements. This is a replica of Samuel Morse's original apparatus. It was quite elaborate at first. You had to turn this handle to send the messages, and the receiver printed the messages out on a strip of paper. But the operators soon realized they could simply tap the message out and decipher the signal simply by listening to it. And this was the origin of Morse code. This was a system for unskilled operators. You had one switch for each letter of the alphabet, and if I press the R, turn the handle, the receiving station would have an identical instrument, and the needle in the middle would go round to the same letter. This is a more primitive version of the same thing. Well, by 1860, the telegraph system had become big business. All the major towns in Europe and America had a telegraph station. The lines became so busy that they had to develop a way of sending the messages at high speed. So you had somebody printing the messages out on paper tape and putting them into one of these machines, a high-speed sender. And at the other end, you had one of these machines, which is a high inking machine. Not working at very high speed at the moment. Okay, that's enough of that. Well, this required a whole army of clerks which had to punch the messages out and then decipher them at the other end. It was while trying to invent an improved version of this that Alexander Graham Bell realized that it might be possible to send speech down the wires instead of simple pulses. Bell's father was an ebullient teacher of elocution and speech therapy in Edinburgh.
Graham, now listen to this poor woman. She has the most terrible problems with her labials. Oh, and she's got a frightful lisp, too.
However, Graham's two brothers then died of tuberculosis, and his father decided to immigrate to a healthier climate.
They had such lovely voices, too. We'll do fine in America.
Around the ragged,
Aged 25, Bell himself started teaching speech therapy in Boston. At the same time, he came up with his idea of a harmonic telegraph. Recruiting a man from the local ironmonger shop called Watson, he experimented, sending several messages simultaneously at different tones, but nothing would make it work.
Oh, it doesn't work.
On June the 2nd, 1875, though, he suddenly realised it could be modified to transmit speech. Bell described what he'd done as transmitting voice-shaped currents. Instead of the electromagnet just being on or off, he was using it to vibrate a diaphragm and produce sounds. If Rex now connects the electromagnet to my record player, and we use the bass drum skin as the diaphragm, you should be able to hear something. The magnet's vibrating the skin, and this is moving the air, reproducing the original sound. This is one of Bell's original telephones. You can see exactly the same arrangement with the diaphragm here and the electromagnet. You listen in through the bottom here. This is a modern telephone earpiece, and you can see this has a metal diaphragm, and the electromagnet is embedded in plastic down the bottom. The principle is exactly the same. Bell's patents made him a very rich man, and he built an enormous mansion in Nova Scotia. He grew rather portly and started experimenting with kites, twin-bearing sheep, iron lungs, hydrofoils, and all things. He became completely fed up with the telephone and wrote, "I have become so detached from it, I often wonder if I really did invent it, or was it just someone else I'd read about?" Bell used the second receiver as his microphone. It works exactly in reverse. When you speak near it, the diaphragm vibrates and creates a tiny electric current in the electromagnet. I can show you this with a loudspeaker. A loudspeaker is just a larger version of the same thing, really, with a paper cone as a diaphragm and an electromagnet underneath. I've connected it to a meter here, and when I move the diaphragm, the meter reads the current. Well, now if I connect it to the second speaker, when I vibrate one speaker, the other one vibrates too. This is how Rex was managing to talk to me at the beginning of the program. But it's not a very efficient process, this is why Rex's voice was so faint. And without any electronics, Bell's idea was really much too faint to be of any practical use at all.
The first practical telephone used a completely different type of microphone. This was patented by Thomas Edison some 2 years after Bell. Edison realized that if you apply a small amount of pressure to a lump of carbon, its resistance changed, so he fitted a diaphragm to a piece of carbon. This basic idea was greatly improved by Reverend Hunnings. He used a whole pile of carbon granules, and we can reproduce this quite easily using a coffee jar top. I've put a couple of bits of silver paper in here to form a contact, and connecting up to a loudspeaker and a battery. If I fill this with the granules, you'll hear it begin to crackle. Then fit a diaphragm, which is just a piece of plastic. If I cup my hands around it and speak quite loudly, you should be able to hear Bell's voice-shaped currents coming out of the speaker. And this type of microphone, in a refined version, was used in telephones right up to the late 70s.
With Bell's receiver and Edison's microphone, the telephone became a practical proposition. At first, the telephone companies had to stress its usefulness in emergencies because so few people had phones that they weren't much use for anything else. This is part of a film made for a New York phone company in 1910. company's efforts were obviously successful. This is a pile of New York telephone directories a few years later. This is one of Edison's first telephones. You have to turn the handle all the time to hear anything through it. It's called the chalk receiver. This one's called the Marriage. It's one of the phones to combine Bell's receiver and Edison's microphone. A lot of the early phones didn't have microphones as such, but they just had these wooden sounding boards which acted as the diaphragm. You just had to speak somewhere near them. This is the bell that called the attention of the operator. This one's the horse collar phone. You put your head right in it for private conversations. One thing that most of these early phones had in common was that the microphone was firmly fixed to the wall or to a base. And this stopped the carbon granules moving around and crackling too much. The candlestick phone, which came into fashion in the 20s, was a sort of compromise. Although you could move the microphone around, it tended to keep the carbon granules at the same angle as you lifted it up. Carbon microphones were gradually improved until they could be fitted into handsets. And in fact, many are still in use, crackling away. None of the early phones had dials. You simply asked the operator at the exchange to connect you to the number you wanted. Early attempts at using male operators are said to have been unacceptable because they were too rude. As the telephone system expanded, more and more telephone operators were needed.
And toll and telegrams and all exchanges too. Just telephone and we will put you through. Ring Abercorn or Otway. This is our half-past noon. Ring anywhere, we're waiting on your phone. Do you want a little warning to make you get up in the morning? Is your house on fire? Do you want to stand a while? Just lift up the receiver, that's all you've got to do.
The rapidly growing number of telephone operators increased the incentive for some sort of automatic switching system. The answer was provided by the versatile electromagnet. I still use electromagnetic switches called relays in a lot of the machines I make. This is a nutcracker I made for an exhibition. The relays control the motor. It's actually quite useful for being able to see what's going on, and they're actually quite reliable. You can see one of their disadvantages though. The sparks gradually erode the contacts away. The first successful automatic exchange was designed in desperation by an undertaker from Kansas City called Almon B. Strowger in 1889.
Not enough people dying hereabouts, unless there's something funny going on. Let's see, there's my arch rival, McGreely. He seems mighty busy all of a sudden. There's Mrs. McGreely going to work in telephone exchange. Hey, telephone.
So sorry to hear about your recent bereavement, but we do have a special offer this week. 6 coffins for the 3
That's
and
it.
interiors.
She tells
and
him
gold
who's
handles,
dying.
of course.
So I'll make my own telephone exchange and cut out the third party.
This is a Strowger selector made in the 1960s, and it's still surprisingly similar. There are 2 electromagnets. One makes this arm climb up, and the other one makes it hunt across, and finally resets it. Behind, there's a large bank of contacts. The arm sits in front. This connects to the dial. These are the clicks that you hear whenever you dial a number. Many Strowger exchanges are still in use. This one's in Norwich. Although Strowger only imagined tiny exchanges with one contact for each subscriber, his selectors were soon being connected together to make larger exchanges like this. The engineers call the system affectionately click and bang. Keeping it all working is quite an undertaking. The contacts tend to get dirty and make the lines noisy, and the selectors need precise adjustment to work properly. Also, the mechanism gradually sheds tiny metal filings, literally wearing itself out. It's quite surprising it was at all. There quickly reaches a level where electromechanical devices become a bit absurd. This is a burglar annunciator built in the 1930s.
These premises are being broken into. Police, Scotland Yard, Police, Scotland Yard, Police, Scotland Yard. This is a Burgot automatic burglar alarm operating at J.E. Fell.
The solution was a whole new technology with no moving parts. It was based on a device invented for telephone exchange switching in 1947, the transistor. It was credited to John Bardeen, Walter Brattain and William Shockley. Bardeen was the mathematician who developed the theory. Brattain was the practical experimenter who actually tried things out. Shockley was the leader of the team, a visionary aloof from the day-to-day experiments. He foresaw more advanced transistors developed years later, and finally disgraced himself with his campaign for bribing people with low IQs to be sterilized.
Okay, fella, you take the money and it won't hurt too much, okay?
This is a modern transistor. A small amount of current in one side switches a much larger amount on the other side. Here I've hooked up the high power side of a transistor to a car battery and a headlight, and if I'm moistening my fingers, I can now switch the transistor with the tiny amount of current passing through my body. Just touching the low power side of the transistor is enough to switch the light on and off. Solid state switching like this has enormous advantages. There are no mechanical parts to wear out, and of course there are no contacts to spark across. This dummy I made for a shopping centre had to work 12 hours a day, and I worked out the spend lights would be switching over 6 million times a year. Electromagnetic relays wouldn't have lasted long, but with transistors it should last for ages. Transistors can actually switch millions of times a second, so fast that speech can be converted to a sort of code consisting of a very rapid string of on and off pulses. This digital code has a better quality, just like the digital sound of compact discs, and it also enables the sound to be processed by digital computers.
Norwich 698 131, thank you. What's your number, please?
Today, computers are transforming telephone exchanges dramatically. The operator switchboard, little changed since 1900, is being replaced by these computer keyboards. The new digital exchange control room looks just like an ordinary office. The system's incredibly reliable. Failed connections have been reduced from 5% to 0.01%, so there's much less for the engineers to do. Occasionally the computer does find a fault and tells them to change a panel. The engineer first has to earth himself to prevent any static electricity from damaging the chips. The panel simply gets posted away to be repaired. The engineers say there's much less job satisfaction than with the old click and bang system. They all go home at 4:30 and the exchange is then completely controlled from Cambridge till the next morning. Like the digital exchange, modern telephones now use electronics. This has enabled them to go back to Bell's elegant original idea of having an identical earpiece and microphone.
Hello, can you hear me better now that it's amplified?
It's now so loud I hardly have to hold it to my ear at all, and the sound quality is much better than Edison's crackly carbon microphone, all thanks to the tiny transistor amplifier. It's surprising what you can do with transistor amplifiers. You're listening to me now through a device that Rex gave me at Christmas last year. When he takes it away from the glass, now he's put it back again, you can hear me quite clearly again.
This little acoustic probe can only pick up minute vibrations, and the window is acting as a diaphragm exactly as a microphone. It's got several serious uses. We can use it to detect a noise on a car engine, so you can actually tell which tappet is making a noise or which bearing has failed. It's got light-hearted uses as well. You can actually hear through a 9-inch wall far better than an upturned wine glass, like grandmother used to use. And you can also, as you see, listen through glass as if it wasn't there.
The other advantage of electronics is that it's also compact. The latest chips and circuits are so small that there's room for a radio transmitter and receiver as well, the cordless phone. There's even room for the very sophisticated electronics in a cell phone, which automatically changes the frequency of its radio as it passes from one transmitter cell to the next. Without the large bell and dial mechanism that used to fill the traditional designs, telephones have lost their distinctive, robust appearance. The electronics will fit in almost any size or shape. Perhaps the most striking thing, though, about modern phones is their sheer quantity. It wasn't long ago that it was extraordinary to have more than one phone in the house.
Furthermore, a kitchen phone at hand when friends call up to chat a bit. Hello, yes, this is Mary. How are you? Bye. They say your kitchen dazzles every eye. A brand new sink, a built-in oven, a new refrigerator, and a phone. A kitchen phone, a bright red phone. I gotta go. Goodbye, goodbye, goodbye. I'll call you later.
Today, most homes have at least two phones, and often a cordless one as well. And with a cell phone, you can be in touch almost all the time, wherever you are. The number of phone lines in Britain alone is growing by about 1 million a year. It's all very convenient, but the telephone does now seem to rule our lives. It's almost impossible not to answer it when it rings.
Oh, bother. Oh, what?
Oh, help.
Oh, dear.
Hello? Wrong number.
Oh, no.
People talk about going on holiday today to get away from the phone.
Hello, Lofty.
Really?
I doubt whether Bell would have ever foreseen how dependent the world would become on his ingenious invention, but I'm quite certain he would never have guessed the elaborate lengths that some people would go to disguise the things.